Hello friends, I am starting this series Identify the Unknown Compound using the proton NMR spectrum. It is just a starting lesson, it is the simplest lesson in only proton NMR is given. I will upload the lot of lecture in coming days which have proton plus carbon, even two-dimensional spectroscopy to how you identify the unknown compound as well as the stereochemistry of the unknown compounds. So let's start with the simple molecule and with simple spectra. It is just taken from one book. So using the one NMR spectrum, the structure of unknown compound X has molecular formula C4H8O2. So 8 hydrogen, 4 carbon, oxygen is 2. Now in your mind maybe oxygen 2 means ether group or carboxylic group or maybe the ester, something like that, and it's a CO absorption spectra in IR frequency, right? So there is no amine, nitro compound and other things, so all functional group possibility eliminated, thio compounds and some nitrogen compounds, right? Amines, nitro, azo or something like, so we rule out all this functional group by using the molecular formula, right? So these has three signals right here. This is the chemical shift given 1.1, 2.3, 3.7. so three signal means three type of proton, right? So I written in spectra three signal molecule contain three type of protons, right? This is our first inference from this spectra. So three type of proton exist means the next is they have given the pattern, splitting pattern. This is a quadret and this is a triplet, right? This is a singlet. So now they have also given integration 14, 11, 15. Maybe this is an automatic integration. Software give the automatic integration. When you click on button integration in NMR, you will get the automatic integration. Now we want to know how many proton are these. I mean each signals. So what is the method from integration? Just add the all integration, and we know this is from formula C4H8O2, 8 hydrogen, total is 40 unit, all integration is added, divided by 8 is 5 unit per protons, right? So 5 unit is representing 1 protons because we know the molecular formula contain 8 hydrogen. Now each signal has different integration, so we divided by 5 to determine the how many protons are. So signal A is 3 proton is 2.2, so we will reduce to round off to nearest whole number. So 11 divided by 5, signal B has 2 proton, 2.2, round off near 2, and 14 divided by 5, 2.8, we will just up, means round up 3 protons, right? So we know this has 3 proton, this has 2 proton, this has 3 proton. So this is a singlet, right? Singlet 3 protons. So in our mind, how many type of functional group having CH3 and give the singlet? So I draw the possibility of 3 proton which can give the singlet. So but the thing is that they give the shift value of this singlet is 3.7. If you consider this singlet, then you can expect this was 2.3 something, this is a 1 point something like that, or near about 1. So only 3.7 give the singlet CH3O group. So we can deduce from up to now, inference up to now data, this contains CO and CH3O. Idea from chemical shift. Otherwise, we can rule out this possibility of this singlet, which is coming at 3.7, right? So it has CO and CH3O. This is the idea from chemical shift, which is 3.7. So we draw the all possibility for this singlet, which is coming 3.7. So we rule out all the possibility of singlet. Aldehyde also gives singlet, but that is 10 point something. That is one proton. We have 3 proton. So OCH3 is possibly. Let's move to this pattern. This has given 2 proton is quadrat and 3 proton is the triplet. Now it is only possible, it means you can say now CVC, the one quadrat will come if they attach to CH3 group, right? And why triplet come when neighborhood has CH2 protons, means there's a possibility highly the ethyl group here, ethyl group. So now you can think about it, give the triplet, it give the quadrat. So only these signals are exist in this NMR. There is the quadrat and triplet. So this is due to CH3 proton, this is due to CH2 proton, right? So integration also give this 2 value, this is a 3 value. So from the integration you can see here the 2 proton and 3 protons are there. This one 3 proton, 15 integration, this one. So from integration and splitting pattern you will receive the ethyl group. Now we have shift in ppm like 1.1, 2.3, 3.7. Now we have data for the singlet. Now we will not focus on this, just focus on this triplet and quadrat. So 1.1 is, so here is the one, I have this one. So methyl group is far away any functional group which has 1.1, means this type of the system is existing. Now the has 2.3. 2.3 is what kind of here? This is a 2.3, like this type of, plus see this one 2.4, 2.3, CH3CO, right? CH2CO. So this proton has attached to CO, plus we have the data of CO absorption band. So this CH2 attached to the CO, right, the carbonyl group. Now and this CH2 is attached to CH3, which is coming here about the this type of system, 1.1. So CH3 of this 1.1. So this CH2 is attached to CH3 and we have OCH3. So this is a possible structure of if you combine the all data from chemical shift and integration. So this is 2 possibility. Now why we rule out this B possibility from this one? Because OCH2 is not possible. If this is a structure, then you will expect this quadrat at 3.7, which is not. So this quadrat is not 3.7. So 3.7 is only one singlet here. So we have OCH3 and O. Now we have a possibility of the ester, not a acid. Acid, if they have acid, we have separate extra peak. And this is the ethyl group here, which can reduce from this pattern, neighborhood pattern, and as well as chemical shift. So this ethyl is attached to CO, building block give me 2.4, and this methyl is attached to CH2, which is attached to CO further. So this CH3, CH2, CO and OCH3 which is agree with this formula C4H8O2 and containing oxygen. जो is just a simple problem. I mean, it's not complex problem. You have to take care about the splitting pattern as well as the integration. How many protons? This has 2 proton, this has 3 proton. That's why this split into quadruplet and this triplet. This is also clue from the integration as well as the splitting pattern. And next is the how you join the backbone. This is helpful from this table. 2.3 is the CH2CO, then CH3, and just skip this, add one carbon here, then CO give 1.1, this is also given 1.1. So this building block is completed by this chemical shift, and OCH3 is reduced from the chemical shift as well as the ruling out of these possibilities. So this way you can analyze three things in problem, like chemical shift, splitting pattern, and ruling out the possibility using the chemical shift, as well as the integration of each peak. So please like and subscribe. I will upload using the C13 proton and NMR combination with 2D stereochemistry of compound by NMR. So I will upload more and more problem set using the proton and NMR spectra. If you like and subscribe, then I will upload. It will be motivate me. Thanks.